Okay, welcome everyone. We are going to spend a couple minutes and talk about exam number one, because it's right around the corner. Exam number one is going to be posted on Canvas at 5 a.m. on Wednesday morning, February 17th. So that's the soonest you can actually start taking the exam. And you have to take it by, or you have to finish it by 5 p.m. on Friday, February 19th, which means that allow yourself 50 minutes. It's a 50-minute exam. It is a timed exam, so you have to allow yourself a 50-minute time slot anywhere between Wednesday morning and Friday at 5 to start and finish that exam, right? So that's the difference between this and the quizzes. Is the quizzes were unlimited amount of time. You also had two chances. For the exam, you only get one chance, and you only have 50 minutes. So make sure you're ready, prepared as soon as you hit that start button. Because once you start, you need to finish within that 50 minutes, just like it were a normal class. I'm planning on 45 questions. I don't quite have it finished yet, but that time seemed to work pretty well last semester. It does mean that that you have to be conscious about your time. I believe there's a countdown clock running on the side of Canvas as soon as you start the exam, so you keep an eye on that. Make sure you answer the questions you know. This is what I would do anyways. Answer the questions you know right away, and then save that time to look up information after you go through the entire exam the first time. In fact, on Canvas, there's a little flag next to each question you can poke, and that way on the side it would say, okay, all the ones that you want to return to, so you don't miss anything too, right? So you can check that out as well. It's going to be mainly multiple choice and true false. I'm probably not going to have fill in the blank because fill in the blank ends up being a real issue unless it's a very easy answer to come up with for fill in the blank, and everyone will have probably the same thing. Otherwise, you have to have every possible situation or every possible answer, and it's a pain in the ass. So expect multiple choice and true false for the most part. All test questions are from the topics from the slides, video recordings, and guest lecture. The book provides great resources, great background information, extra pictures and things, but I'm not going to have anything on the exam that is strictly from the book if we did not cover it within these presentations, right? It could be something that was said in a lecture that not necessarily on the slides, so that you got to be careful of that. You do have to watch the lectures. You should have been watching the lectures all along. The exam, just like the quizzes, is open book and open notes. You can't go to the internet and Google any of this stuff. You can't ask your classmates. It's not a group exam or anyone else, right? Covers chapters 1, 2, 20, and 3. So general requirements, existing conditions, earthwork, and concrete. I will say that there are some small calculations you have to do. Probably do it without a calculator, but if you're someone who likes to have that backup, it might be good to have a calculator out. I'm okay using your cell phone with the calculator on your cell phone, whatever floats your boat, whatever works best for you. So looking at the topics, chapter 1, we cover general requirements. Things you want to be familiar with are the building design team, who's on it, what is each member responsible for. What about an industry or reference standard? What are those types of standards? Who's responsible for those standards? Who writes them? Where do we find references to those standards? What about codes? Who writes the codes and who enforces those codes? We discussed barrier-free design. Remember making our buildings more accessible. What are those or examples or considerations? Sustainable design considerations. To become LEED certified, what does that process look like? And sustainable building strategies. Moving on to part 2, we talked about construction documents and project administration. What is in that project manual and in the drawings, right? What about the master format? Remember there was a 1995 and then a massive revision in 2004. What about the numbering? How would you find something like, say I wanted to find something about acoustic ceiling tiles, what section would I go to? What number would I go to for that? Responsibilities of the contractor and how that's different than the design team, right? Sequence of tasks from bidding to project award. How does that look? And it does depend on the type of contract it is. What's the difference between a design build versus a design bid build? So be familiar with that as well. Legal land surveys, we discussed 3 different types. Also, what do each one of those look like? What are some characteristics? Could you identify one if you saw one, and what type is being used? What about any potential limitations? And expect to have like an example where you could look at the example and then identify what type of land survey it is. What about the difference between demolition and excavation? Remember that. So that was below ground and above ground. Demolition above, excavation below. Keeping those straight. Then we moved on to earthwork, which is chapter 20. Starting off with site preparation, getting the site ready to build. What's included in that site clearing, and what site characteristics can affect the design of building components, right? Which way is the sun facing? What trees are going to stay and what are going to go, and how does that affect the design of the building? Soil, we're talking about the soil and soil characterizations. There were 4 major types that we discussed. How do we classify them, and what type of testing can we do on the soil? Remember sieve testing and breaking down into different types of soils. There are silts and sands and clays. What are these? What are these, and are they good and bad for our soils? Bearing capacity, plasticity, cohesion, settlement. So think about those 4 major soil types and what does that do as far as our bearing capacity, plasticity, cohesion, settlement. Which soils gives us problems and why? And what strategies do we have to counter moisture and temperature problems in soils? Moisture in soils is probably our biggest issue that we deal with. Earthwork, what is excavation? What are the 3 types of excavations? Once we excavate, we had 4 types to systems to support that excavation to keep the soil from coming back in on us, right? And within those 4 types, we had 3 types of bracing systems. How do we brace against the walls for those deeper excavation systems? What are the benefits and drawbacks of each one of those? How do we compact, backfill, and fill soils, and why do we do it? Why do we want that compaction of the soils? What is grading, and why do we do it? What specific problem can grading help us solve? Give you a hint, grading is so we can have the runoff of the water. Moving on, speaking of water, what other water problems with erosion, surface water, groundwater? What methods can we use to control our erosion? Who dictates what is acceptable? What is surface water and our sources of surface water, and what are some strategies for controlling surface water problems? What is groundwater? So now we're below the ground, below the surface, right? And how can it be a problem? What is soil capillarity? Remember, soil can suck water up. Which soils have high capillarity, and how does capillarity affect a groundwater table? Remember how that can change the whole table of where our sitting water is actually located. What strategies do we have to protect slabs on grade from groundwater problems? And then we moved on over to concrete. We began with concrete material properties. What is concrete made from? What are those key components, and what does each ingredient do? What are different types of Portland cement, and what are they used for? Remember high early strength or low heat of hydration, things like that. What are some sustainability considerations and strategies for each concrete ingredient? Cement mixture vocabulary. What is the difference between cement, mortar, and concrete? Hopefully everyone knows the difference between cement and concrete by now, right? Even though that gets mixed up in the general population all the time. What are common concrete admixtures, and what do they do? Remember, super plasticizer, make it more liquidy, or something like that, right? What is cement hydration? That's that chemical reaction that's going on between the cement and the water. And how does particle size affect this? So remember our aggregate size, how does that affect cement hydration? Once concrete has finished that hydration process and it is hardened, what about its strength, and what about its durability, and what affects that type of stuff? So keeping with the theme of concrete, we talked about mixture proportioning. What happens with the strength, durability, and workability when we change this water to cement ratio? We add more water, it becomes more workable, but we lose strength and durability. What about when water cement ratio goes up or down? How does it affect it? What about if the cement content only goes up or the cement content only goes down? So we're talking about strength, or if you have too much, you get that scaling, right? Aggregates, we talked about them being well graded. What about when when they're gapped? That means there's only big particles and small particles. There's nothing in the middle. What effect does that have? How do we choose that maximum aggregate size? Remember we said there were two things affecting that. One was distance from rebar to the edge of the form and overall size of the form or thickness of the slab. What about the concrete testing and placing? And what is a slump test? How do we do this slump test? Remember the rotting and everything else? Cylinder test, air meter test, we're measuring all this stuff. Who is responsible for formwork design and what are the components of formwork? Remember we have our plywood and then we have our joists and our whalers and bracing, things like that, right? What are good concrete placement techniques? What can happen if we don't adhere to them? Why do we consolidate, vibrate concrete? Those are somewhat related. What do we need to be careful about? Don't want to over vibrate because it can separate your material. Same thing with placement. What we want to keep is the concrete to be a constant mix as we move from the top to the bottom of our wall or slab or whatever we're looking at. And so it's a matter of not dropping it too much, things like that. What are the steps of finishing concrete slab and what equipment is used? So you can see the slides on those steps and what we're doing for the finishing of concrete. We also talked about joints and curing. What is bleed water? Remember the water is bleeding to the top of the surface. How does it affect finishing and curing of concrete? What are 3 types of concrete joints and when are each one used? What is curing? Keeping that water, that moisture in there. Why is it important? What are some methods of curing? How can curing affect strength and durability? We know curing is good. Why? What about these concrete construction accessories? Why do we add steel reinforcing to concrete structures? Remember, concrete's very weak in tension, strong in compression, so we add steel. What 2 types of steel reinforcing are 2 types of steel reinforcing discussed in class, and how are each of these sized? So these are the welded wire fabric and the rebar. I.e., for example, what is the diameter of number 5 rebar? Remember, those are 8, so this would be a 5/8 diameter rebar. How do we describe the distance of rebar overlap? Remember, that's in diameters. So if I had 20D and it had number 5 bar, what is the overlap? Could you figure that out? What are rebar chairs? It's keeping it off the floor of the pour, right? And what are embeds embedded into the concrete? Then we finished up with concrete special topics. We talked about spread foundations and when each type is used. 2 types of slab on grade and how they are different. Precast concrete, benefits and limitations. What are pre-tensioning and post-tensioning? Remember, both those are done before load is put on our concrete. It's just a matter of when we're tensioning our cable or tendon. Why is it beneficial and how are each one of these done? What is precast concrete and what are benefits and limitations? What are concrete toppings and when do we use them? And what is a cement underlayment? And what are the pros and cons of gypsum and cement base? Remember, gypsum is much lighter, but of course we have some drawbacks to the gypsum based over the cement. The one thing that wasn't in there that you should also be familiar with are the slides from our guest presentation with cold and hot weather concrete. I should have put a slide in there. I didn't summarize that, but it's still content that will be on the exam. So that's what I have. Good luck. Review. Get organized. It's the #1 thing you can do. Shoot me an email if you have any questions or comments, testing strategies, things like that. And I'll talk to y'all later. Thanks.